In this video, I'm going to go through some examples of finding inverse functions. So in an earlier video, we talked about a function as taking numbers called inputs in the domain and applying the function to those inputs, and that results in outputs in the range. And in this example, if we look at this output here, that comes from two possible inputs, and that's okay for a general function, but if we want to think about inverse functions, we need to consider a particular type of function called a one-to-one function. And for a one-to-one function, we cannot have this situation where one output comes from two different inputs. So when we're thinking about inverse functions, we either need the function itself to be a one-to-one function, or if it's not a one-to-one function, sometimes we can restrict the domain so that it is a one-to-one function. So for example here, we could restrict the domain by just getting rid of this point, and then we're not going to have this arrow here, and this output here now only has a single input, and so we've restricted the domain so this function is one-to-one. And if the function is one-to-one, then we can define a inverse function, which we denote as f with a -1 as the exponent. So that stands for f inverse. It doesn't stand for f to the power of -1. It stands for f inverse, and that takes numbers from the range of the function and turns them into numbers in the domain. And so let's go through some examples of how to find inverse functions, and it's essentially a four-step process. So I'll go through each of the four steps for each of these four examples. So first step is to just write down that y, I need to change the color of the ink, that y is equal to the function x plus 2. And the reason we can do this is because we're thinking of y as representing the output of the function. And then we're going to solve this equation for x. So if I subtract 2 from both sides, I'll have y minus 2 equals x. And as soon as I've got x isolated on one side of the equation, I'll have a function of y on the other side of the equation, and that's going to be my inverse function using y as the argument of the function. One final step is, instead of having y as the argument of the function, it's nice to have x as the argument of the function, and so all we do is switch y and x, and then we can express the inverse function using x as the argument instead. So the inverse function to f of x equals x plus 2 is f inverse of x is equal to x minus 2. So not really surprising. The original function we added 2, the inverse function we subtract 2. Let's go through those steps for a couple more examples. So f of x equals 3x. So remember, first step, just write y equals the function. Next step, solve for x. So if I divide both sides by 3, then I'll isolate x on one side of the equation. So the inverse function in terms of y is y over 3, and if we change the argument to x instead of y, then we can write f inverse of x is x over 3. And again, that one's not surprising. The original function we multiply by 3, the inverse function we divide by 3. Let's do a slightly harder example. F of x equals x minus 3 over 2. So first step, write down y equals the function. Next step, solve for x. So if I multiplied both sides by 2, I'd have 2y equals x minus 3, and then if I add 3, I'll have 2y plus 3 equals x. And so the inverse function in terms of y is 2y plus 3. And if I just change the argument so that it's x instead of y, I can write the inverse function is 2x plus 3. And again, that makes sense, because if we look at the original function, it takes the argument x, subtracts 3, and then divides by 2, whereas the inverse function takes the argument, multiplies by 2, and then adds 3. Let's do one last example. So in this last example, this function as written is not one-to-one, because, for example, if x was equal to 4, I would have 4 times minus 1 squared, so 4 times 1, so 4. But if x is 6, we'd also have 4 times 1 squared, or 1, 4 times 1, would have 4 again. And so in this case, for this function, the input 4 and the input 6 both lead to the same output. So thinking back to our diagram before, it's as if this is the 4 and then the one that we erased is the 6, and they're both going to the same output. So it's not a one-to-one function as written, but if we restrict the domain, similar to the way we erased that point in the diagram at the beginning of the video, if we restrict the domain so that x is greater than or equal to 5, then we do have a one-to-one function. Okay, so with that restriction, let's go through the steps. So first step is to write down y equals 4x minus 5 squared. Next step is to solve for x. So I'll do this in a couple of steps maybe. So let's do a couple of steps. So first, let's divide by 4 both sides. So we'll have y over 4 equals x minus 5 all squared, and then let's take the square root of both sides. So square root of y over 4, I could either write that as literally what I just said, so square root of y over 4, or instead I think it's a little neater to write square root of y over 2, because 2 is the square root of 4, if we're just thinking about positive square roots. And then the square root of something that's squared will just be the x minus 5. And then final step, running out of room here, maybe I'll just do it down here. Square root of y over 2 equals, square root of y plus divided by 2, and then add 5 equals x. Okay, so the inverse function in terms of y is square root of y divided by 2 plus 5, and then if we just change the argument so that it's in terms of x, it will be the square root of x divided by 2 plus 5. And we need to just write down again that we're restricting the domain here. X has to be greater than or equal to 5, and we need to have that restriction in so that the function is one-to-one. So there's a few examples of finding inverse functions.